Hello, hello everyone.
Hi, Alexander.
Hello, Alex. I guess we're going to leave a few minutes for people to join as we usually do, and we start at 5 past.
Yes, with pleasure, Pascal. So maybe Pascal, we can start. If you want, I'll give you the word. I'll give you the floor.
Oh, no, please do it. I mean, you prepare the slides. It's only available that you
okay.
prepare them.
Okay, sure. Okay. Well, I mean, okay. So, thank you, Pascal. So hello, everyone. It's 5 minutes past the hour, and in our old SCHC tradition, we can start a meeting. Next slide, please. So yes, so this is an official IETF interim meeting, and as such, all IETF policies apply. So by participating, you agree to follow IETF processes and policies. If you are aware that any IETF contribution is covered by patents or patent applications that are owned or controlled by you or your sponsor, you must disclose that fact or not participate in the discussion. And of course, this is only a brief overview of the full policies. Please read all the BCPs that are listed here, and especially take into account all the anti-harassment and code of conduct documents. So next slide, please. So today we have an interesting agenda. So there is an excellent document that is advancing at the for using SCHC with diet, and we are going to have an update of that draft. I think it's in working group last call, in a different working group. So it's really important that we provide the feedback to the authors as soon as possible, so that they could advance the work in their working group. So this is like the first major point, and I think that we need to allocate as much time as possible to that item. And then there is another point, which is about the seed allocation for the young data model for SCHC. So Laurent is going to present that. It's being a topic that we discussed a couple of times already. So I think that, we need to, to jump the trigger. I don't know the exact expression what it is, but just move on with this and request the seed allocation at IANA. And for that, I'm just going to have a very short overview of like what is expected from us, I think, right now, so that we as a group say yes, that is okay for us, and that we can send the document to IANA, right? So this is why I take 5 minutes before Laurent's presentation. So do you have any other point that you would like to discuss today? Okay, so no additional points. So then we can continue. We can move on to the next slide. Let me.
Sorry, I pressed the wrong button.
Okay.
Let
me. Okay.
Right back. Oh, okay.
Okay, I'll do it. Yes. Yeah, because actually I added a couple of slides and I think, oh wow, I didn't update the slides anyway. Oh, I didn't update them. Wow. Okay, let me update the slides. I made a change like 5 minutes ago, I think, and I'm surprised it's.
There are multiple versions of the slide showing when you have to select one, so maybe the other one is there too, but the 0 is still there. So
Okay,
maybe you clicked on the 0.
Or maybe so give me just a second. I'll update the latest version, because I mean it's
You
there are
just
too much.
leave that and share the other.
Yes. So give me a second. It's being uploaded. Sorry for that. Okay, it's done. I will reload the slides. Yeah. Okay, you have the different versions. Oh, that's true. Okay, I haven't seen that yet. So we were at that point. So we are not having a meeting. So this was one of the points I really wanted to discuss. We are not having a meeting at the next IETF in Bangkok. So I wanted to ask you, because today is our last interim as that is scheduled, and I wanted to see if you would like for us to meet on March 11th, which is the week before the ITF. Like the ITF is starting on Saturday, I think officially. The hackathon is starting on Saturday, or like 2 weeks after the ITF, which gets us to April the 1st.
So, Alex, Eric here, and
Yes.
sorry to be the bad guy on this. Normally, you are not allowed to make an interim before the IETF because people are traveling, including myself, by the way.
Yeah.
So this one is out. April 1st, beside the joke, that will be fine.
Okay, yes, it will be a good meeting then on April the 1st.
Sorry about that.
No problem. Like I was I was aware that it's not an ideal slot, but it's good to have the official like an official excuse for that. So it will be April the 1st. I think like the week just after, it's not a good point. Like, it's not a good moment. So we'll get on April the 1st, right? From there on, I wanted just to do a very short overview of the documents that we have in our working group today. So the first thing is that we published an updated version of the SCHC architecture. So it was a very intense work to get where we are, and like it took a little bit time to synchronize a lot of different point of views and to try to to be specific enough on the terms and yet be generic enough so that we don't close all the doors. So the author, me personally, I'm pretty happy with where we are, and I'd like really to thank Pascal and Anna, and also Laurent, of course, for this multi-year effort. And I think that now we can go really fast with that document, right? So if you have any issues, any questions with it, please just shoot, and we'll try to integrate that as soon as possible, right? I think that we need to get into fighting order so that we finish it. I mean, finish it, that we incorporate all the elements that are necessary as soon as possible, right? So that's the good news. Now, I saw that we have a draft that is expiring soon, that is SCHC over networks prone to disruptions. And I wanted to check with the authors if they are considering submitting an updated version. So Anna is here, Edgar is not here.
Hello. Yeah, we are working in a new version. I think we are doing some inter meetings among us. So we have not a date, but we are working on it.
Okay, so that's a good thing that you're working. That's a really excellent thing. And yes, please try not expiring the draft. Like you can just push a minor update, just that we know that it's
Okay.
it's an active work.
Yes.
Right. Yes, Laurent.
Yes, and for ICMP compression, I don't remember the status. We had a last call, a working group last call or something like this.
Oh,
So,
I need to double check. Okay, let me write this action. I don't remember. Last call.
And typically, if you go on data tracker on the document and you look at the history, you can check. Which is the reason why I keep asking, put the state into the history. That's annoying, but.
Yes, you're right. Okay. Okay, so that was the second point. Then And then like there are a couple of points here that actually I've submitted a couple of drafts just before actually I was a little bit away because there were like several concepts that we've been working on some time. I've been working on some time and I wanted to document them and I wanted to present them in like a very a little bit more detailed manner. And that will come maybe in our next interim. And I just like noticed that they all show up here in the related internet drafts. So I wanted to say just one word about this. And if anyone is curious of reading of the different drafts. So basically, it's a little bit of continuation of the work that started with the FEC rule, the FEC rule format, where we have like a new type of rule, which is for FEC fragments that we can use, right? And there have been a lot of discussions during the time about, okay, well, how can I use, for example, if I have several smaller messages and I can aggregate and I can put in one bigger message and send it over the radio, and that's interesting for aggregate for delay tolerant networks, for example. And so like a very short draft presenting, okay, well, you can aggregate messages and how it works. And actually a work that there was a work by Carles and Sergio. They started working a little bit on using the fragmentation as a reliability mode. But they went in a different direction, and I wanted to continue the discussion with them, and there is a different direction here, which I think is complementary. So Carles is co-author of this draft as well, and it's just basically saying, hey, well, you can use the fragmentation as a reliability layer, right? So if you have individual fragments and some of them get lost, well, we can use the fragmentation state machine to recover them, but they are individual messages, right? It's not like one big message getting split into several messages. So all these things are there, right? And the first thing is like this is not like an official presentation of them. If you want to go and read them, I'll be very happy. I'll make a very detailed presentation next time. And for all of that work, I'm really open to, like, if you want to collaborate on that, please, it will be my greatest pleasure. And one thing is where that leads is that basically you can combine your SCHC, like you can have bits and pieces of processes and combine them to make like the type of SCHC process that you want, which will be specifically adapted to your environment. Like in some cases you may say, well, like, I just want compression and fragmentation, and that's what I want, and it's like 90% of the use cases. But in some cases you may say, well, I want compression and fragmentation, and then I want FEC on top of that, like, and then you can build your process for that. Or maybe you want okay, I want compression and then I want aggregation, and then I want some reliability on top, and then I want to add a FEC on that, right? And so I think this does not, the goal of this draft, of this particular draft, is not to become an RFC or to continue as an independent draft, but just to provide an input for the architectural draft, right? Just so that we have this in mind, right? And this is all open to discussion, right? But I'm starting to work in this manner, like documenting my thoughts and pushing them in draft so that we can get that we can discuss them here. Right. So yeah, I just saw that all these drafts, they show up, and yeah, that's normal, right? And I just wanted to give you a little bit of an explanation of the whole thing, right? So with this being said, I have nothing more to say. Sorry, like, and I will give the word to Daniel and his co-authors, so that we can focus on this item.
Hi, everyone. So, so in this discussion, we're gonna describe our work on IPsec compression and we are going to focus this presentation only on the SCHC aspects. So this is a work that we're driving, among others, with Mariam, Sandra, William, and Steer. Next slide. So as Alexander mentioned, this work is in Working Group LASCO, and that Working Group LASCO start in IPsec-ME on January 8th. And so we do have IPsec aspects, but we also do have SCHC aspects. And what we do anticipate with that work is that, I mean, we received a lot of comments. We believe we addressed them all for now, and we want to, this week, we want to be able to say, well, we believe this, all the comments have been addressed, either on IPsec or on SCHC, and we can move those documents forward. The working version of our work is on GitHub, so and it's available at the link indicated below. So, okay, so this is on this slide we represented what we call an IPsec packet. It's in fact, I mean, when we say IPsec, it's more ESP, which is one way to do IPsec. Because IPsec is a suite of protocols, so you have multiple of those. But in this case, we are mostly focused on this type of packet. But even just for simplification, the way we should, I'm going to explain IPsec is I mean, IPsec has different modes, and maybe for simplification and clarity of the purpose, we will only consider the tunnel mode, but the draft is considering every mode. So it's just to make the conversation easy. So what is doing IPsec in tunnel mode? It takes an IP packet, it encrypts that packet, and it sends it on the wire. And on the other hand, you receive that encrypted packet, you have to decrypt it, and then you extract from this encrypted wrapper, you extract the original IP packet. So in that packet, I mean, the inner IP packet, so the one being encrypted, is the payload data. And this payload data is, we add some padding as well as an indication on what type of packet is being encrypted. Then we encrypt it. Encrypted means both encryption and we append the signature at the end. And then we basically put an identifier, which can be seen as, well, this identifier is used by the other hand to retrieve the right key. Because as you can realize, I mean, you can only decrypt with the key that has been the exact same key that has been used for the encryption. So we need to actually make, I mean, IPsec requires to work that we, when we send an encrypted packet, that the receiving side is able to receive that packet and associate that packet to the a context that contains the key for the decryption. So, I mean, in this document, we are handling with compression, and we defined. So as you can see, IPsec is handling a lot of what we call payload structures, and what we defined in this specification is 3 little compressors that compresses structured payloads used by IPsec or ESP. And I mean, they compress it, so you have a payload as an input, and as an output, you have a compressed payload. And we have 3 of those. One that happens for the inner IP packet, one that happens for when you have the wrapper of ESP payload, so just before the encryption. And then once you have done the encryption, you have a header. And we also consider that this header can be encrypted. So these are the 3 compressors we're considering into this specification. So now let's see, I mean, how SCHC is being used in that specification. So we use SCHC as a practical means to illustrate the capability to compress and decompress a structure payload. Any element of SCHC that pertains to aspects other than compression or decompression, like fragmentation, falls outside the purview of this document. And the reference to SCHC is solely for description's purpose, related to the compression and the decompression. In fact, it is not anticipated that the general SCHC framework will be integrated into the ESP implementation into the Linux kernel, let's say, or into a hardware implementation. So as I mentioned, we're mostly focused on compression and decompression of specific structure, and the structure payload addressed in this specification pertain to the internal structures managed by ESP for the processing of an IP packet. Consequently, the compression and decompression process outlined in this document represent supplementary steps handled by the ESP. So I'm just wondering if that's pretty clear for everyone, or if anyone has any concern on how we use SCHC at that point.
I think Anna has a comment. Anna?
Yeah, when you talk about three compressors, what do you mean? You have three SCHC compressor differently in each part?
Yeah.
You are only using three compressors out of SCHC? What is your three compressors?
So for, I mean, maybe if Mariam or Sandra wants to answer, I mean, please feel free to jump into the conversation.
Yeah, can you hear me?
Yeah, we can hear you.
Okay, hi. There are three compressors where I cannot say there are three SCHC layers as they are defined in the new architecture, because they all run in the same process. It's just that they happen at different stages of the encryption process of IPsec. But they do follow the same procedure that was defined in SCHC, so that we replace the headers at each stage by a rule ID and a compression residue. And if possible, we also elide those fields.
So I think that the problem here is a problem of terminology, because when you talk about compressors and that you have a reference to SCHC and so on, this is not SCHC terminology. So that's why it's confusing for me. And unless.
So how do you call an entity? You have an input, and I mean you have compressions, and then you have an output. How do you call that if it's not a compressor?
Well, for example, instead of three compressors, I will say that I have three stratums, and each stratum has a SCHC header, and in each header, I don't know if there is really three SCHC elements, but perhaps I only have one. I don't know if there is some nodes or there are multiple nodes in your architecture. So,
Anna, I think I understand
you are using. Sorry.
Yeah, no, I understand where the confusion comes from. This is not, so we kind of reversed the attempt that we did to follow strictly the new SCHC architecture, because we realized that it had more complexity than what we needed. All these three compressors, they happen in the same machine, in the same process, actually. It's just that they happen at different times. So we don't quite need a SCHC header for each layer of compression, because it's always the same ID, is DSA of the IPsec session.
So that's
So
why I say that it's terminology, because we don't say layer, we say stratum. So okay.
But we didn't say layer.
No, we say stratum. So that's why.
No, but
I think that the problem is terminology most of the time.
yeah, but we're not. So in the latest version of the document, we're not saying that this is described according to the architecture of SCHC. We're just saying that we use SCHC as a reference to describe how the compression of headers is applied, but it's not SCHC per se.
and we do not mention layers, for example.
What do you mean that
So
you are not doing exactly SCHC? You are doing something else.
maybe we are using SCHC rules to describe the compression. That's
But that's the problem, because your SCHC rules is not really a SCHC rule. So as soon as I understand, when I read your draft, the SCHC rule is not exactly the SCHC rule. So it's very confusing for me.
So
but I let you continue with your presentation. Okay. Perhaps it will take out some depths. Okay.
Yeah, I think so. So let's go on.
I had some
yeah,
comment. So if you want, I do it at the end, but it depends.
No, please.
Okay, so yeah, for me, the second paragraph is quite ambiguous. I can read it in the way that we are putting the name SCHC, but we are not doing SCHC. So that's one understanding. And the other one is that we just focus on compression and we don't care about fragmentation. So it's, for me, this paragraph is confusing. And for the answer to Sandra about stratum, I think we are describing exactly the same thing. A stratum may be complex in when you do ASCII art, because there is a lot of dash and dots, but in implementation is just changing the reference of the rule manager. And you have the same implementation, you have everything exactly the same. The only thing is that you don't have the same set of rules for each stratum.
Right, but then according to the new architecture, I will need to have a SCHC header for each stratum, right?
Yes, you need to have one SCHC header for each stratum, but this SCHC header can be empty.
Yeah. Go ahead, Daniel.
So from an implementation point of view, it's nothing.
Okay. So one thing is, I may understand that we can define those with stratum, but for example, when we read the SCHC, how SCHC is being used in CoHAP, stratum were not existing, so I have the impression that we can do. We are closer to a very simple use of SCHC, and bringing the full SCHC machinery might not be needed and might be actually more confusing to what is being done. So this is why we wanted to, we are not against clarifying things, but we don't want to give the impression that we're going beyond then expressing compression and decompression. So Eric
Yes.
has a comment.
Yes. So yes, Eric. Yes, perhaps time to go to next slide so we all understand better.
Okay.
I find it interesting to see how outsiders understand the SCHC architecture. Useful for the ID if there is some misunderstanding. Yes, fully agree with this, Eric. Yeah.
So I think this is the next slide. No, next slide. Okay, so SCHC rules and SCHC static context in this specification. So, I mean, what we need to really understand is that IPsec is encrypting a packet and decrypting that packet. So it means that we are able, I mean, IPsec already provides some means for an incoming packet to be able to bind that packet to a very specific context that contains at least the keys. And the key, you only have one. So, because and that key must be the same used for, I mean, not compression, but encryption and decryption. So when you have an incoming packet, IPsec is able to associate that packet to a context. IPsec is calling that context a security association. And when you have a receiving packet, it's being encrypted, the receiver is also able to bind that packet to the security association that has been agreed between the two peers, right? So in this document, we adopt a similar approach with compression and decompression, is that we, in those security association, we provide all the parameters that are necessary to derive the SCHC rules associated to each packet, to each structure payload. So it means that ESP, when he's processing the packet, he knows exactly what he needs to do, and there is no way to carry information within the packet almost. So so we have a unique rule that is applied for the compression and the decompression for each structured payload. So this guarantees that security association is linked to a single rule, thereby allowing the rule ID to be omitted. The rule associated to each structured payload is generated based on specific parameters referred in this document as attribute for rule generations. And those attribute for rule generations are negotiated via IETF. So when you have a packet, I mean, you have agreed that context between the peers, and you know exactly which rules is being applied. So this is basically how the packet is being processed. So you have the inner IP packet. He's going into the IPsec stack. You have what we call a security association lookup, which is basically which context is associated to that so that packet. Inner IP packet is not yet encrypted. So first, we apply some compression to that inner IP packet. Then we do the wrapper, and inside the wrapper, you have this compressed IP packet. Then you can compress the wrapper, which is called ClearText ESP. Then you proceed to the encryption, and then you provide the ESP header, and then you can compress that ESP header. So this is the steps, and then you send that packet. So the receiving side is just doing the reverse. Any comment, any questions?
Yes, so first, to me, it looks very very understandable. I like it very much. Looks really clean. I need to think about. So it's interesting the choice that you made, but that's probably related to the application. I mean, you're the expert in IPsec about like not including the rule ID, you know, because you could benefit of having multiple rules in the same IPsec tunnel. But I mean, if you don't care about that, of course, like you can say, well, we say that the rule ID, like the rule ID is is 0 bits. I mean, there is only one rule ID, and like there is a way around it, but it's very understandable to me. And thank you for taking the effort of actually using the notation about the compression and decompression. Yeah, and these were things that we did in DTLS, like something that's very, very similar to that, and I know that it works. So at least for me, it looks really good.
Okay. Eric?
So Daniel, thank you. That explains a lot. Now, I wonder, because the inner packet can be thousands of different things, UDP, TCP in the same essay, right? So how can we get a single rule and not multiple of them?
Yeah. So it's basically we only compress what IPsec can compress for now. So we compress UDP, everything related to transport. We don't. I mean, the application, for example, we do not we do not go beyond what is not related to IPsec.
So, but if you do in transport mode, so you can compress UDP, for instance, header,
yeah,
or TCP header, most probably. But if you go in tunnel mode, you can go way more and achieve way more compression.
So we do for in this context, because I mean, though you can do that, there is nothing that prevents you, but you never go, for example, HTTP in IPsec. You never say, oh, my HTTP traffic, I want that to go there. And
anyway, it will be TLS encrypted, right? So we cannot compress anymore in the case of HTTP.
Yeah, so in that case, I mean, we used the what is being currently implemented for the traffic selectors. And those are do not go beyond UDP or TCP. I mean, you can specify SCTP, but usually it's internal mode. You say, I am encrypting everything into that thing. So we do go up to UDP or TCP. And
okay, so basically you use the knowledge about the traffic selector because you know the traffic entering the tunnel is matching the traffic selectors. You can compress a lot. Okay, got it. Thank you. You're smart. And by the way, it's very similar, the key negotiation and the rule negotiation. In IETF, there was also a way to compress, right? At some point of time, there was an API compression protocol or whatever that could be negotiated by IETF years ago, early 2000.
Oh, yeah. That has nothing to do.
Yeah, but it's similar things.
Okay,
somehow,
yeah. So, it's a full debate also.
Okay, no problem. Thank you.
But yeah, this is completely orthogonal to that.
Yes. So just a minor follow-up from what Eric said. So I mean, I see the value of doing the things as you do, and it is you're the author. I think you can decide to stay as it is, to leave it as it is. Probably it would be a very low-hanging fruit to just say, hey, well, there is to leave the door open, and to say, well, like there can be a rule ID, a single rule ID, in which case, like, we don't send it, like it's 0 bits. I mean, I need to look exactly how to formulate the sentence to be compatible with RFC 98.794. 98.24, sorry. But just to be SCHC compliant. But probably you can say, well, like it's the security association that provides the size of the rule ID. So basically,
yeah, that's something that can be done, but I would say in maybe in another profile that is based on that one.
I mean, I think it depends on you to think about it, because I mean, if you include it right now, it can be like, well, by default we use it like it's 0 bits, so but like you don't close the door today, and then you can have like an additional draft or something or an example. At least it doesn't close the door to people to say, hey, well, like I'm using like an 8 bits, I don't know, 8 bits of size of rule ID, which gives me a 255 rule IDs, and then maybe in like the vast majority of cases, all the people are just going to have like a very simple implementation that is like everything is hard coded and like it works. But maybe imagine that someone tomorrow is using this for satellite communications or interplanetary communications, and they say, well, like we have these profiles and we're just going to be using like some magic with the SCHC in it, right? So it's just
And
things
so,
that are not there today.
why would why would we need to have more rule IDs?
I mean, the point is that you can have like the point is that imagine that you have several different flows going over
Okay,
the same
okay, I
IPsec,
see.
IP,
Okay.
IPsec, and like you or
Okay. No,
then
okay,
for
I
each
see.
flow you can install a different rule.
Okay.
Okay,
I see. That's so the way I see it is that we should clearly mention this is a restriction that we put here, and I mean, but clearly that's I mean, I would defer to another draft or another protocol. If I'm just specifying why we can do that and why we could do otherwise. That's something we can probably add into that.
yes.
Yeah.
Yes, I mean, from like you're the domain expert, and like I'm saying, it seems to me like a low-hanging fruit. Like then,
Okay, we will think of it.
Yeah, sure.
So, if I go to the next slide, where we actually try to speak SCHC, so we clearly represented a SCHC. I think a SCHC payload. And what we mentioned is that the rule ID is a unique identifier for each SCHC rule. It is included in packets to ensure the receiver applies the correct compression and decompression, maintaining consistency in packet processing. And where we said the rule ID does not need to be explicitly agreed upon and can be defined independently by each party. The rule ID in DITESP is expressed as 1 byte and always elided, as rules are uniquely determined for compressors. So what following up the comment from Alexander, it seems that we can maybe add a few words here to detail how that could be used with with different rule IDs. And what we say also is that the SCHC padding in SCHC serves the purpose of aligning data to a designated boundary, which is typically byte align. And in this document, we assume that this field is not used in either of our compressors. Any comment? Yeah, Alexander.
So just one question here about the padding that you presume that it's not used. You haven't, like, you don't want to use padding.
Yeah.
It's not a problem for IPsec. Okay.
It's not. It's not because we handle that in we do handle that, but then we have one way to handle it, and it's easier to have one way to SCHC proceed that packet.
Yeah. Okay. So then you just say, well, SCHC padding is not used. Yeah.
Exactly.
Sure.
Yes, just one point on SCHC padding. It's on you cannot be larger than 1 byte. It's 7 bits maximum in SCHC.
So the SCHC padding cannot be
larger than a L2 word in the RFC. It means usually it's 1 byte, so you can have only 7 bits of padding.
So you can only have 7 bits. So we're talking bits.
Yeah,
okay.
bits.
You can have we can have, but we don't need to have those we don't. I mean, we want that padding to be completely deleted, and the reason is that we don't. We have no way to determine the length of the payload, so we never know the padding we need. So we remove all those paddings and we add specific structures that mention the length of the padding at the end.
Because in a pure SCHC algorithm, you receive something that is aligned on 8 bits. To simplify, you know the rule ID because it's something in a binary tree. Then you get the compression format, so you know the either the size of the residue, and then after the residue, you take all the L2 to all the bytes that exist, and what remains after all these bytes is the padding.
Mm-hmm. But in our, I mean, in order to determine, you need I mean, if you say after this byte it's only padding, you need to know the length of the residue and the payload, for example.
Yeah, there is no
and
there is
ESP
normally
doesn't
you don't put the length of your payload. It's just because the assumption is that the payload is a number of bytes, and so this way you can remove the padding.
So I'm wondering if Mariam or Sandra want to complement, but we try different ways, and I think the main problem we have is that we don't have that length available. So the way IPsec is constructed is that you take everything and you read the last bit, and from that one you determine the length of the padding instead of having the length of the payload and the residues.
Okay,
So my question would be, is there any problem to say we do consider bits and we don't need the compression to be byte aligned?
I will say maybe I don't know about IPsec, so maybe I will say something.
No, but chic.
Yeah, but I will say maybe something stupid. In your first slide, you show some padding, and maybe one solution is to say that the L2 word is 32 bits instead of 8 bits, and this way maybe you may have a more generic padding.
Lauren is talking about the first figure that you show with the ESP packet format. So I think that the thing is that we have that padding later before the encryption happens. So it doesn't matter that the compression, the compressed packet at the beginning is not byte aligned, because we will still do padding later to comply with the requirements of the compression algorithm, if it's block aligned or byte aligned or.
Yes, actually, it is IPsec specific. So we are using check padding in the way to comply the IPsec requirements. For example, at the stage that it wants to do the apply the encryption algorithm, it needs to be byte aligned. So we apply the check padding at that stage, not all the stratums, only the stratum that needs that encryption algorithm. So that's what we say, that we have 3 stratums and we apply check for all of them, but the check padding is only in one of these where the encryption algorithm is going to be applied. I guess if something should be added, please correct me.
No, in fact, if this padding is, so the one on the slide here is important, maybe you can consider it as some headers and you do compression on it. But I don't know if it's very important for the algorithm. For me, it's really for when you send it to encryption, you need some blocks, and this block has a certain size.
So yeah, so what we do, so there are multi way to do the padding, and what we try is to have a consistent way to do, and in that way we assume there is no SCHC padding, so that I mean we can handle how padding is being done with IPsec. I mean so this is it is I mean, we're basically we're doing I mean instead of handling different ways to do the padding, we just say okay, in SCHC we have no padding, and then we know we need to have a byte alignment, so this is how we handle that, and so we have only one way to do this. So my question would be, I mean, is there anything that prevent to say there is no padding in SCHC, that we ignore the padding?
Padding is natural in SCHC because your residue is on bits, so you have no alignment on the residue.
Mm-hmm.
So it means that when you send something on layer 2 is byte aligned. So the SCHC compression by itself makes something not aligned, and so we need to introduce this padding, but we never put the length of the padding because we take the assumption that every block we are sending is a byte, or all the payload is byte aligned. So what is remain after these bytes is padding.
Yeah, but
in this case, we don't have a layer 2 technology that gives us that restriction. We do need to comply with the block alignment that the encryption algorithm requires. So I guess that's so we don't need to solve the padding at the SCHC. With the SCHC padding, we can do it later.
But that means you will have to bit copy with an offset of bits. I mean, we discussed that at the call we had, Daniel, and one possible solution was to make the rules so that the residue was byte aligned. It's just the way you write your rule. Make sure that you compress this into that. Doesn't mean that has to be the minimum bits. You can waste a few bits in your residue just so that you're byte aligned.
Yeah, but it's so what I think and what we looked is that because you take the length of the packet, I mean it works fine to ignore the bytes, the remaining bytes, if you know where your payload ends, and we don't have that. I mean the length of the payload is determined by, I mean, instead of having the length of the payload, IPsec is providing is saying you take everything except some length of the padding. And so we did the same thing here. So we just mentioned the bits, the length of the padding, so that we can remove those. We take the full thing, we look at the end, we remove that, and remove the padding that needs to do the byte alignment. But that mechanism is handled by, our ESP thing, not by SCHC.
Okay, so what you mean is when you build your encrypted payload data, the result has to be shifted in memory by a few bits to stick to the SCHC residue.
Because, you receive it, you decrypt. Then you look at the end.
But what you decrypt, what you have to give to your decryption engine is initially not byte aligned. If you
No,
have
in
not
that
made
case,
it so that the shake residue of the object before, the first thing, the first compression, the one on the ESP header,
yeah,
that one, if it has a residue that is not byte aligned, that means that when you copy the payload, the encrypted data right after it, it has to be shifted by bits. But what we said last time when we had this call is, well, we don't want to have a shake padding to a byte align before the payload, before the encrypted data. What we do is we make it so that the rules don't generate the absolute best, but they generate something which is byte aligned. I think that's what we said last time.
yeah, but you need to know the length. That's my point. No.
But the shake rules, I mean, oh yeah, that's another thing.
Yes, and maybe then just one. So we are at the time of the meeting. So
Okay.
just a very minor question here is, why don't you want the padding? Like, if it would, I think it can save you headaches just saying, well, it's byte aligned and like the SCHC padding is there just so that everything here is byte aligned, and then we don't have to care about this. Like just a food for thought, right? It may be just an easy issue out of it, right? If it's just implementation complexity, then like you need to pad somewhere, so you need to solve somewhere this problem of padding, right? So if you say, well, let's just put the SCHC padding there so that we know that the residue and like it ends at the byte boundary, so it can be quite easy in the implementation point of view. But I think that's probably a food for thought on how do you handle that. Do you want to put some constraint on the compression rules so that you get what you compress gets out byte aligned?
So my understanding, and maybe I'm wrong, I think it's not possible unless you add a 4-byte length field to understand what is the size of the payload. So so the balance is I'm saying 4-byte, but it could, a multiple bytes field. So the balance is either you just you use a few bits, in our case 3, let's say, versus 4-byte. So I think it's you need to understand. You need to know where the padding starts. And what we say, instead of having it expressing the length of the full field, the full packets, we just express from the end the length of the padding, which is it is expected to be smaller.
Okay, well, that's probably that's like I am not sure if
yeah, sure.
but I understand your questioning, your trouble there. I'm not really sure that you need this length. I'm
Okay, yeah,
because
sure.
like at looking at the SCHC structure, normally you should be able to see, okay, the compression it's that big, like unless you have a variable length fields, which in most cases you don't. When you're dealing with IP and TCP or UDP, like in most cases you don't. And even if you have like a variable length field, normally it's the field that has this part. So, but I'm missing there something. So maybe that could be like a topic on the mailing list, like a separate topic. If we can break this down, like say, hey, like a question on the padding. So these are our issues. This is why we don't want the padding there, the SCHC padding, and probably like people will say, yeah, well, so, but like for me in SCHC, nothing forbids you to say from saying we don't use SCHC padding. So
Okay.
that is SCHC valid thing. Like all the discussion here is like, well, why do you want to do that? Probably you might want to keep the SCHC padding, right? But nothing forbids you from saying, hey, we don't use that.
Okay.
Guys, we are
We can
reaching
bring that
the
to
end
the
of the
mailing list.
hour.
Yes.
Okay, so I just have one more, maybe one more slide. So very briefly, so these are basically all the parameters that we use to generate the rules. So as you can see, or maybe not, we only defined 5 parameters. and all the others are already part of that security association. So we don't have a complete mess. But now the big question for us and the SCHC working group is that one. I mean, in a lot of cases, we do have specific ways to handle the compression and decompression. So we call them compression decompression actions. And we want to, and we give them some names. We don't really care if we call them compute minus star, but we want to be able to be able, that in that context, the compute star is going to do that. The compute star is going to do that. So we'd like to understand if that is fine with everyone. If we say, in addition to the compression decompression action defined in SCHC, this specification use CDAs presented here in this table. They are either refinement of compute CDA or the result of a combined CDA. So I think it's really a terminology. If you, compute is, the way I understand compute is that you do a specific function, and we want to be able to say, well, that specific function is going to be this, and we want to understand how we can call this. Yeah, please. I see. Please take the mic.
Pascal, Laurent? Laurent?
Sorry, I forgot to start my mic. The first point is that it's not very clear in the draft, in the RFC, but I think you can use compute because compute is related to the field ID you are using, and you can make your own compute things. The point is that the compute is based on information you already have. So, for example, the length for CRC, and generated is not covered by compute. The other point is that I see in the draft that you call IANA to define some variables. Normally, you have more to create a young data model where you will put this information.
So, so how would you call generate then? If
you can call it generate.
Okay.
It's not a problem. It's not what compute does.
Okay.
Compute is just based, for example, the layer 2 address that we put in the draft, normally it could be a compute. It's the same semantic. It's a compute for the address. And it's based on something you already have, is layer 2. Okay. Generate is something you don't know because you are generating it. So it's not covered by compute.
Okay. But is the text fine for you, or
Not really. I think you should follow especially in the next. For me, I'm lost. I like to see the table you have in RFCs of SCHC that gives you all an example of packet, and you say, I have this field, this field, this field. And so this is totally informal, and the formal part goes to the young data model. So if you need to create a new field ID, you put it in the young data model. If you need to create a new CDA, you put it in the young data model, etc.
But we can think of the young data model maybe for a next step. But for this draft, suppose we don't have young data model.
You need to formalize things. So you have to list all these things. But
but we have a clear definition on how to implement those.
Let's go like this. But I think young is a companion to SCHC.
Yeah. No, we have no problem doing young, but later maybe, not for this draft.
Okay, guys, we are really late, so I suggest we end
Okay.
it here. And Daniel, yes, at the call, I also mentioned you that there was this work to be done on your
Well,
engagement.
thank you everyone
Anyway.
for the feedbacks.
And
we will bring that
yes,
to the
let's
mailing
continue
list.
on the mailing list. And yes, and thank you, Daniel, for coming. And let's make sure we speak when we say padding. By the way, let's make sure we discuss the right padding length. At some point, there was this misunderstanding whether it was the few bits that SCHC had to line bytes or the padding at the end of IPsec. So please, in the discussion, don't just say padding, say SCHC padding or ESP padding, just to make sure.
Okay. Yeah.
Yes.
We will
Yes.
clarify. We will make sure. This is the okay. We'll bring that.
And which stratum padding we are talking about as well. Okay.
So I
Bye
think
then. Thank.
the GitHub version is much clearer because we changed that yesterday, but we will clarify that on the mailing list. Sure.
Well, you still have a few days to publish.
Yeah.
Okay. Thank you, guys.
Thank you. Bye-bye.
Thank you. Bye.
Bye-bye.
Thank you. Bye.
Thank you.
Bye.
Thank you.
And good-
Bye.